Now you're asking just how cold was it, Grandpa? Well, imagine the summer being as cold as the winter. I don't know if you like cold weather. Maybe you're listening from a cold place like Norway and you think winter is just fine. I don't care. And the Swedes say there is nothing like winter. If you have proper clothes, then it's all okay. Well, I have hiked in the Himalayas. I have lived in the US. I went to Alaska and very, very cold places. And let me tell you, it's cold and miserable when you wake up in the morning, and it's nice to sleep under the blanket, but getting out of the bed is very problematic for me when it's winter time. So during the last ice age it was 4 degrees colder on average than it is now, and that is the global means, which means the colder places would have gotten much colder, and warmer places like India would have gotten colder as well. That's quite some climate change. 4 degrees, you probably don't understand what that means, but the amount of energy you have to lose to produce global cooling of 4 degrees. Wow, that's really cold. For thousands of years it was non-stop winter in much of the world, and around every 100,000 years that long winter comes back again. In the next section you'll find a recipe for these ice ages. In the other sections I already introduced, and I also mention in this book, the ice albedo feedback. You make a little change and the ice begins to grow, and it is very bright, and it loses more and more sunlight. It gets colder and you go more ice, and soon you have ice age. But first, it might be handy for you to know how our seasons actually work. Why is it warm in the summer and cold in the winter? Lots of people think it's because the earth is closer to the sun in the summer than it is in winter. No, that's not the case. But maybe you are already learned this and say that's not what I think anyways, right? But there are people who still believe that, or they don't know enough. Well, that's complete nonsense though, because while it's summer in the northern hemisphere, it's winter in the southern hemisphere, which means we are not really closer to the sun or farther from the sun. If one hemisphere is having summer and another hemisphere is having winter, if we are closer and farther, both hemispheres should be warmer or colder, right? Then half a year later it's the other way around. Then it's winter for us in the northern hemisphere, let's say, and summer in Australia. So they can celebrate Christmas in Australia wearing bikinis and swim trunks on the beach, because their Christmas, December, comes in the peak summer. It is true though that the earth isn't always the same distance from the sun. The earth circles the sun once in a year, as you know. That circle isn't actually a circle, it's a bit oblongated. It's called an ellipse. It's like the shape of a hula hoop when you lean on it a bit, because it's flexible. It's a nice circle, but if you push down a little it becomes like a egg shaped a little bit. When it's summer in the northern hemisphere, the earth is actually 5 million kilometers farther away from the sun than in the winter. Half a year later it's the other way around. It's the summer in the southern hemisphere, and the earth is closer to the sun than it is in the southern winter. So the distance from the sun doesn't have much influence on the seasons. We still get summer and winter because seasons happen because the earth is a little bit tilted. If you have the earth going around on this plane, it is not like this, it is tilted a bit like this, which you may already know, right? So in our summer the northern hemisphere is turned, so if you're going around like this, sometimes you're pointing to the sun and sometimes you're pointing away from the sun. You can tell that because the days are longer in our summer and the sun is higher in the sky, longer days give the sun more time to warm the earth, and when the sun is higher, its rays travel a shorter distance. It's straight down instead of coming at an angle through the atmosphere, so more heat remains in the atmosphere. The rays of the sun are also extra strong. Every piece of skin or earth receives more sun than in the winter when the rays are coming. So you can see the flashlight here. In India we call it the torch. So So it is coming at an angle here, but here it is coming straight down, so you can see bright spot here when the sun is higher in the sky, but here you see more diffuse light when the sun is on the horizon. Isn't it a nice way to do the experiment? You can try that at home. Get a flashlight from your parents and do it. Okay, so you can easily imitate this with a flashlight or a spotlight. Point the flashlight straight at the wall so that you see a nice round circle of light. That's how the sun shines when it's high in the sky. Now shine the light in onto the wall at an angle. The same amount of light comes out, but it's spread over a larger area, so every piece of wall gets less light and less warmth, just like the earth in the winter. Here we are looking at the nice image. Here you are in a satellite or a spaceship going around looking at, where is my flashlight? Well, your flashlight is here, and here is Earth. If you're in the northern hemisphere, here you're pointing to the sun when it is summer in the north, and then you come here in the fall in the northern hemisphere. So here you have to read, and in I can't read it, so, and in the south it is the other way around. So you have spring in the north but fall in the south. Here you have fall in the north and spring in the south. So you have winter in the north as opposed to summer in the north here, but the south is having summer. So you see, imagine how this is happening. There are lots of animations on YouTube. NASA makes videos. I have many courses on my YouTube channels where I show the animations and so on and so forth. So make your own Ice Age now. Maybe we'll come back and talk about that in the next podcast, because I want to keep each topic a little to itself. We mentioned how ice ages happen with the ice albedo feedback, but winter and summer seasons naturally happen because the earth is tilted and it is going around the sun in a approximately circular path, which means it's one hemisphere is pointing to the sun in one season and the other hemisphere is pointing to the sun in the other season. Now imagine that the tilt is not constant. You may have already learned that it is about 23.5 degrees to the orbital plane at this point. Maybe that changes over time because of gravitational pull from the other planet. Let's say, you know what gravity is by now, I hope. It's why the apple falls. If you throw a ball, it comes back. If you drop something, it goes to the ground and so on. That's gravity, in case you don't know. And maybe the earth wobbles like a top. If you play the top as a child, you know that when it's spinning fast, it's standing up straight. As it slows down, it begins to wobble like this. Maybe earth wobbles like this, and maybe how oblong or elliptical the orbit is changes over time. So these are called orbital parameters, and they do change over thousands of years of time scales. The tilt goes from, now it is at 23.5 degrees to the vertical. If you take the orbital plane and draw a perpendicular line, Earth is tilted at 23.5 degrees. Maybe it becomes less sometimes, maybe it becomes more, which means you will be pointing more to the sun in your summer or less to the sun in your summer, and you will be pointing away more from the sun in your winter or less. So these things can change the way energy is distributed and how strong the summer is or how cold the winter is. We said summer and winter happen because of the tilt and the orbit, and now we are saying maybe the summer is not always as hot and winter is not always as cold, not because we are again going farther and closer from the sun, because we're just changing the angle of the tilt and we are wobbling like this, and we're changing the distance a little bit, but that is not always the most important thing, right? So we are, adding concepts, so you have to now track everything. It's like we say one thing and then we say another thing and they are related, so 1 + 1 is 2, which is easy to do, and then we'll add another thing and we'll say 1 plus 1 plus 1 is 3, but then we'll have adding 1 1 1 1, and you have to keep tracking, which means you have to remember all the ones and what they mean and how they add up. This is how we learn, right? It's not difficult. You just have to listen again, read again, remember, and ask questions and so on. So let's come back and have some more fun about how we can build our own Ice Age. Wouldn't that be fun? Well, let's do that.